Good morning, Tahmina Khan is here. In this video, I will explain the concept of how to sketch and interpret displacement time graph and velocity time graph. It is in the syllabus of A-level Mathematics Mechanics, paper 4. This is video number 2. In video 1, I have explained the concept of basic term and terminologies which are used in kinematics of motion in a straight line. So before I begin, you can see on the top my blog address, on which I have put up all the links of my previously made videos, and this is the Gmail address. You can send your query onto it. So let's just start with the topic. First of all, the graph or constant velocity. So we will see the relation of displacement time and velocity time graph here. So in the displacement time graph, the line which is going like this, slant line and straight line. So what does it represent on the velocity time graph? So this line on the displacement time graph will be represented by a straight horizontal line. So it means the object was moving with a constant velocity, right? So this is number 1 point. And another characteristics of the velocity time graph is that area under the curve in the velocity time graph gives you the distance covered by the particle. This is the concept which we have already learned in maths in grade 11. So it is the same concept. Now we will see two displacement time graph, and then we will draw corresponding a straight line velocity time graph for those displacement time graph. So let's look at this one first. Now, if you see here, the line is straight line which is going like this. I have just shown you a minute ago that this means constant velocity, right? And we also know that the gradient of the displacement time graph give us the velocity. Now what is happening here? If you see, this is a distance time graph, so no distance is covered and time is passing by. So when the time was 0 to 20 seconds, the object was moving with a constant velocity. Then from 20 to 40 seconds, the object is stopped. And then from 40 to 50 seconds, the object is coming back, because it is coming back to the origin from where it started the journey. Now, another thing which you can notice here, this part is less steeper compared to this. So here the constant acceleration was covered in 20 seconds. And here in 10 seconds it came back. So let's see on trajectory, what does it mean? Trajectory mean if I express the same graph on a straight line basically. Let me hide this graph first. I don't want to show it first. Velocity time graph. Okay, so trajectory mean at time t equals to 0, object start moving in the right hand side direction. Start moving with a constant velocity for 20 seconds. So it is going here for 20 seconds and it has covered 20 meters. Then it is stopped for 20 seconds. So break the rest. And then it is coming back from where it started, which is here. And again the same 20 meter distance is covered. So after 50 seconds, it is back to the place from where it started. Let's see this graph on the velocity time graph. Okay, so for this portion 0 to 20 seconds, I will express the line like this. Now how did I get this one? If you take the gradient on this part, this point is 0, 0 and this point is 20, 20. So if you find out gradient, you remember the formula y2 minus y1 over x2 minus x1. So if you apply that formula, you will get gradient 1. And the gradient of the displacement time graph gives you velocity. So that's why it is written 1 here. So a straight line is showing constant velocity for 20 seconds. And then this line from 20 to 40 is on the 0. Right? 0 velocity. So 0 velocity means the object is stopped. And then when it is coming back, if you notice here, it is coming back. The direction has changed, so velocity is negative. So that's why we have drawn this small line in the negative side, -2. And within 10 seconds, the velocity was 2 meter per second. Again, if you take out the gradient here, this point is 40,2 and this point is 50,0. So you can apply gradient formula and you will see that velocity will come -2. I can show you here. So if you see here, I am just trying to show you here that I have taken this point which is 40,20 and this is 50,0. So I have taken these points here and this is a straight line, so I have applied gradient formula and I got -2 answer. Because it was a displacement time graph, so gradient will give me velocity, and that's why we are drawing this line here at -2. Okay, so now let's see another displacement time graph. Let me hide the velocity time of it. We will just figure it out in a while. Okay, so now look at this. For 0 to 20 seconds, the shape of the graph is like this, and then it is a straight horizontal line, and then it is going up. So what are these three segments are representing? Displacement time graph. So what is this representing? What is this representing? And what is this? So can you see? When this, if you look at this, it is actually what? Displacement is not increasing or decreasing. It is stuck at 150. So it means object is at rest. So now see here. It is here. 20 to 40, this straight line is showing object is not moving. Now here the velocity is decreasing. So when the shape of the curve is like this, it is decreasing. When the shape of the curve is like this, it is increasing on the displacement time graph. So it is showing here that this velocity you can see is decreasing, right? And then it is stopped for 20 seconds. And then again it is increasing for next 10 seconds. How did we get this? This velocity 10 at 0. So can you think, why did we get here 10? What is the reason for this? Any idea? Okay, so maybe you have gotten an idea. Now let's see. If I see in 20 seconds, I have covered distance from 50 to 150, which means actually 100 meters I have covered, right? So if I see here, area under the curve in velocity time graph gives us distance, right? So this is the shape of a triangle. So if I apply here the formula for triangle here, it is half into base into height. So this is 20, and suppose this I don't know at the moment. So I'm writing h here. But what I know that area is 100, which I know actually from here that in 20 seconds 100 meter have been covered, right? 150 say 50 tak is 100. So I'm writing here 100 and solving it, and I get h is equals to 10. So this is how I have gotten this height. Okay, so now, and for this it is increasing speed, so that's why the gradient is positive. It is like this. Okay, so now let's look at the other example. Now there are many questions in which description is given to you and you have to draw the velocity time graph and you have to find the total distance. So I have taken here two examples. For example, here a particle accelerates uniformly from 20 meter per second to 32 meter per second in 15 seconds. Then move with constant speed for 25 seconds and finally decelerates and comes to rest in another 10 seconds. So the requirement of the question is that you have to draw velocity time graph using this description. So let's see here. According to this, particle starts from 20 meter per second to 32. So from 20 to 32 I have drawn a straight line. It is a velocity time graph. For 15 seconds means I will write here 0 to 15. Now then for another 25 seconds, so 15 plus 25 is 40. So this is 25 seconds. And description is saying it was moving with a constant speed. Now constant speed means it will go with the straight line. So speed is same, which is here 32. and after that it is saying it is decelerating and coming to rest in 10 seconds. So after 40, at 10 seconds, which will be 50, I will draw a straight line like this. So this will give me the velocity time graph for this description. Now if I have to find the total distance covered, you can see there are three shapes: trapezium, rectangle, triangle, and it is a velocity time graph, so area under the curve will give me the distance. Or I can do trapezium, and this is also a trapezium. Can you notice? This is also trapezium. So it's up to you. You can find the area of two trapezium or trapezium, rectangle, triangle. You will get the same answer. Let's see what I have done here. So I have found area covered under the two trapeziums, right? So you remember the formula: half into height into sum of parallel sides. So for this trapezium, these two sides are parallel, this one and this one. So this will be height. So 15 is height. So one side is 20, other side is 32. So this is how I have done here: half into height into sum of parallel sides. Now look at this trapezium. So the parallel side is this one and this one. So what is the length of this side? 40 minus 15, right? 40 minus 15 will be 25. And what is this length? 50 minus 15. And what is the height? 32, because height is a distance between parallel sides. So I'm writing here area of a trapezium: half into 32 into 25 plus 35. And then I'm adding up the two areas, and it is 1350 meters. So this is the distance covered in first 50 seconds. Let's see the last example. Okay, so in this question the description is that particle accelerates uniformly from 11 meter per second to 26 meter per second with acceleration 0.4. So you will take the line straight from here to here, and time is not given to us here at the moment, right? And the acceleration here is 0.4. So let's see how did we get this time. We will see in a while. It then decelerate at this until it comes to rest, and then it is decelerating and coming to rest. So we will see how did we get this time. So did you think how did we get this answer 37.5 here? Because it was not given in the description. Okay, so we applied the concept of gradient here. Basically the acceleration is given here, which is 0.4, and it is actually the gradient of this line, right? Because it is a velocity time graph, and in the velocity time graph the gradient gives you the acceleration. Okay, so that's why this is 0.4. So this point is 0, 11. This point is t, 26, because right now we don't know this t. So I have written here the points, and then I'm applying gradient formula, and which is equals to 0.4. So this is giving me the value of time, which is 37.5. Similarly, I'm finding out this point. I know this point and I know this gradient. This gradient is -2. So similarly apply the gradient formula and get this time. So to find out the total distance covered in 50.5 seconds, I will find the area under this trapezium and area under this triangle. You can see here. So for triangle it's very simple. This minus this will give you this base. Height you already know, 26. So half into base into height, and trapezium is half into height into sum of parallel sides. So it will be 11 plus 26. So this is how I will apply the area of a trapezium and triangle, and I will get the distance covered in the whole journey. So with this, and one thing, it is always mentioned that write your answer in 3 significant figure. So that's why I'm writing it as 863. So with this, I will end this video. Thank you very much for watching it. If you have learned anything from this video, I would like you to press subscribe and like button. You will get the indication of my new videos. Take care. Allah Hafiz.